Tin Pencil, and welcome back to my channel. Welcome back. This would have been day 28 of the July LeetCode or the JuleetCode challenge that I was working on. And again, I was out of town, so I wasn't able to create any like live coding videos or tutorials just because of the equipment that I had. So this for 28 was question number 486, predict the winner. But before I jump into this, I actually really want to tell you guys that I was obsessed with this question. And I didn't really do as well as I wanted to on this one, I don't think. Unless this is the one. No, yeah. So this one did really well in terms of runtime, but it didn't do that well in memory. But if you guys don't know this, because this is like obviously a programming channel and like I do a lot of code, that's like what I do for a living. I actually own horses. That's like been my lifelong thing is I ride, and that's what keeps me like sane. And I own racehorses. Like I get them as yearlings and then I help get them to the track. So I don't actually like race them, but I do all their foundational work and all of their kind of upbringing just because I'm not like a licensed trainer. So and I don't have the time for it either. That's the other thing, at least not right now in my life. So on racetracks, they do have people who calculate odds and like predict when, like actual mathematicians, which I think is really, really neat. And I don't think they quite understand what goes into it, but like they're calculating these things up until a few minutes before the race starts. So it's just kind of fun to have this question with that kind of idea of like predicting the winner, just because I like not even a couple days ago watched a horse that I had as a yearling who is now a 3-year-old go into this maiden claiming race and watching all these odds get calculated. And she was like not even in, like she got 7th. So she wasn't at 7th out of 8th, but she is, they calculated her odds and everything. And it was just really exciting to like predict the winner of that. And we use kind of a similar thing. So anyway, regardless, I just wanted to say that was like, this question was really, really cool for me. But anyway, I'm done talking about it. This was day 28. So let's go through the question. You were given an integer array nums. 2 players are playing a game with this array, player 1 and player 2. Player 1 and player 2 take turns, with player 1 starting first. Both players start the game with a score of 0. At each turn, the player takes one of the numbers from either end of the array. So num0 or num0, num0 or nums length -1, which reduces the size of the array by 1. The player then adds the chosen number to their score, and the game ends when there are no more elements in the array. Return true if player 1 can win the game. If the scores of both players are equal, then player 1 is still the winner, and you should return true. You may assume that both players are playing optimally. So they go through these examples and the constraints, and this is what you're given when you load the page. So I'm not going to go through that part, but I will start in this area here, which basically just initializes 2 variables. The first one being n, which is the length of the nums list, and dp, a 2D list matrix, the size of n by n, initialized with zeros. So this matrix will be used to store the dynamic programming values. So then we get down into this loop, and this loop just initializes the diagonal of the dp matrix with the values from the nums list. So we then get into this area here where we have nested loops, which iteratively fill the dp matrix using dynamic programming. So this outer loop that you see iterates over different lengths of subarrays starting from 2 up to n, essentially. And the inner loop iterates over like the possible starting positions of left. So the variable right is calculated as left plus length -1, representing the ending position of that subarray. So then within that inner loop, you can see we choose the values of choose left and choose right. They're being calculated. These values represent the difference between the score of the players whose turn it is and the maximum possible score of the opponent. So the player has essentially two options: choosing the left element, which was num's left, or reducing the subarray to left +1 right, or choosing the right element, which is num's right, by reducing the subarray to left right -1. And then the DP matrix at that point is then updated with the maximum amount of those two options. So leaving us with the return for this, which is after that matrix is filled, the method returns true if the score of the first player starting at position 0 is in fact greater than or equal to 0. So indicating that the first player can win or tie the game according to the rules of the problem. So this question is just using dynamic programming to determine whether the first player can win a game, where each player takes a turn selecting those numbers from a given list. And basically the goal is to maximize the score difference between two players. So not quite like horse racing, but I actually did do something similar to try to calculate some odds, and it was really, really fun. So this was that solution. I hope that makes sense logically to you guys. And again, I didn't do as well as I wanted to on this. I did on runtime, but not quite on the memory side of this, so I will be revisiting this problem again later. But thank you guys so much for watching. I'm going to have the GitHub repo with the solutions for this in the video description down below, so feel free to fork and clone, make it better, make it worse, have some fun, learn something, and yeah, share with me what you make. And thank you guys for watching again, and I will see you in the next video.